When we graph using a function rule, we're going to start by creating an XY chart. When we create an XY chart, we get to pick the values for X and calculate the values for Y. When I pick the values for X, I can just pick any numbers I want to, but picking very large or very small numbers can make the arithmetic difficult. So it's often a good idea to focus on what is the actual arithmetic you're going to have to do in the problem, and to pick numbers that will play nice with the function rule you have. Notice when you look here in this function, whatever we pick for x, we're going to have to multiply it by 1/2. Well, even numbers are a lot easier to take half of than odd numbers. So for this particular problem, it would make a lot of sense to pick even numbers rather than odd numbers. It also makes sense to pick a combination of negative numbers, positive numbers, and 0, since in some types of function rules, very different things can happen with negative numbers versus positive numbers, or with the number 0. So, keeping in mind that even numbers make sense in this particular problem, and that we want our numbers to be close to 0 so that we're not using big arithmetic, let's choose -4, -2, 0, 2, and 4. We're going to plug each of those numbers in. Now I can calculate right in the table, or I can calculate off to the side. So if I do f of -4, that means I'm going to take -4 and replace x with a -4. I would say -1/2 of -4 plus 2. Well, since negative times a negative is always a positive, and 1/2 of 4 is 2, this is 2 plus 2, or 4. So I'm going to add the number 4 to my table. If I do f of -2, I'm going to take -1/2 of -2 and then add 2. Well, again, we know that a negative times a negative is a positive. So I'm going to get a positive. 1/2 of 2 is 1. So I have 1 plus 2, which is 3. So I can add a 3 to my table. Next, I'm going to try 0. So f of 0. So I have -1/2 of 0 plus 2. Well, no matter what I multiply by 0, I'm just going to get 0. So when I add 2, I'll get 2, and I can add 2 to the table. Next, I have f of 2. So -1/2 times 2 plus 2. Well, this time I have a negative times a positive, so I know I'm going to get a negative number. 1/2 of 2 is still 1, and -1 plus 2 is 1. And finally, f of 4. So I have -1/2 of 4 plus 2. A negative times a positive is a negative, and 1/2 of 4 is 2. -2 plus 2 is equal to 0. So I've filled out that table. So we've done step 2, substitute any values we like. And next we need to graph the points, step 3. So when I go to graph these points, each of the lines of the table represents an ordered pair. So I have the point -4, -4, the point -2, -3, 0, 2, let's back up for a minute. I just graphed those last 2 points incorrectly. -4, +4, -2, 3, 0, 2. Oh, and I'm off again. These little tiny grids are hard to see on my computer. 2, 1, and 4, 0. As we look at that, we can see that this seems to be kind of a constant line. It's following a constant pattern. And this is a function rule that represents all possible values of x, not just the ones that we happen to pick. So notice how this keeps dropping down 1 and over 2. If I keep going down 1 and over 2, I could actually find some more points to go across this pattern. And I can see that this is going to keep going forever in this direction. So it says draw the line. Don't forget the arrows. When we have a function rule like f of x equals, that means x can be everything. So although we picked a few numbers to plug in, that's just enough to get us to see what's going on with the pattern. We then need to follow that pattern to draw the entire line. The arrows show that this line goes on forever, both up and to the left and down and to the right. It's not just stuck on this one little graph. So the arrows are important to convey that the line is everything and not just what we drew. We also need to label some points. Personally, I like to label the y-intercept. That's the point where the line crosses the y-axis. And sometimes the x-intercept, the point where the line crosses the x-axis. But any 2 points you pick to label on the line are fine as long as they're labeled correctly. Let's look at another situation of a function rule, a linear function rule. This says the function c of h equals 12.5h plus 30 represents the total cost of renting a truck for h hours. We're asked to graph the function given that the daily limit is 12 hours. Okay, so if the daily limit is 12 hours, I can't rent the truck for more than 12 hours. I certainly don't need to pick any h values that are more than 12. And if you think about it, I can't rent the truck for any fewer than 0 hours. So the smallest number I could need to pick would be 0. So I know that the domain of this function, all the h values are limited between 0 and 12. I don't need to pick anything outside of that range. So when I go to set up a table, it's not going to be an XY table this time. It's going to be an C of H table. Same thing as XY, but H is going on our x-axis and C of H is going on our y-axis. Just like we did in the last problem, we can pick values. Now, since we determined that 0 was the smallest and 12 was the largest, it makes a lot of sense to go ahead and pick 0 and 12 as 2 of the values that we're going to plug in. We can pick any other numbers we want between 0 and 12. We could probably rent the truck for half of an hour if we wanted to, so we can even include decimals or fractions in our XY chart. But that just tends to make the arithmetic more challenging than it needs to be, so personally I don't think I would. The other thing I see is I've got a 0.5 on this number. That's like having a half. So kind of like our previous problem, even numbers make a lot of sense here. So personally, I think I would pick like maybe 2 and 4 as additional numbers to plug in. So if I do C of 0, 12.5 times 0 plus 30. Well, 12.5 times 0 is just 0. So it would cost me $30 if I wanted to rent the truck but then not take it anywhere. If I do C of 2, I have 12.5 times 2 plus 30. Well, 12.5 times 2 is 25, and 25 plus 30 is 55. So if I rent the truck for 2 hours, it will cost me $55. C of 4 says 12.5 times 4 plus 30. Well, since 12.5 times 2 was 25, times 4 will bring me to 50, and 50 plus 30 is 80. So if I rent the truck for 4 hours, it's going to cost me $80. Now, C of 12 is a bit of a larger number. You might want to grab your calculator for this one. When you do, you'll see that 12.5 times 12 is 150, and 150 plus 30 is 180. So the most it could cost you to rent this truck is $180, since you're not allowed to keep it for longer than that. We're also given a grid, and so we're asked to make a graph. Now that's tricky. We've got a little tiny grid and some really big numbers, so we're going to have to think about what scale makes sense. As we're looking across the axis, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 if I go right to the edge. So let's allow ourselves to go to the edge so that we can go ahead and let the x-axis go by 1s. That's just enough to fit. But on the y-axis, we're clearly not going to make it to 180. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines available to us. 11 doesn't divide evenly by 180. If I only used 10 lines, I could count by 18, but that seems fairly awkward and not to work super well. There doesn't seem to be a really easy scale to work with. If I could go by 10s, that would be nice, but that doesn't really fit. It does look like I could fit if I went by 20s, so let's go ahead and do that. So if I have 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, I know that everything will fit. and it won't be too terrible to graph. So first, I can see that 0, 30 would be right about there. 55, I'm going to have to estimate a little bit. This would be 40, 50 would be in the middle, so I'm going to be slightly higher than that. If I go up to 80, I will be right here. And 180 for the 12 will be right there. 20, 30, 20, 40, 60, 80. Yep. And when I graph two of those points, I just made the rookie error of not paying attention to my scale. So C of 2 gives me the point 2, 55. So when I go to 55, I'm out here. And C of 4 equals 80 gives me the point 4, 80. So 2, 4 up to 80 puts me out here. That makes my line make a lot more sense when I start to come across. Now, in the first problem, we put arrows on the ends of our line. On this problem, we won't, because we're limited. We can't rent the truck for fewer than 0 hours or for more than 12 hours. So this line does not go on forever. It's simply the line given here on our graph.